Hi everyone. For today's class, we'll talk about interesting but broad topic, just like the lesson last time, no, or the previous lessons, not just the lesson last time. This probability distribution, remember. But what I did there, I just explained the context. So we'll do similar thing for this one because this is broad. I'll just mention you the context of this, what we're talking about, knowledge representation and knowledge theory, but our focus is more on the knowledge representation. Knowledge theory is like more philosophical, actually. It talks about origin of knowledge, but somehow kind of connected. But if you will, as we discuss later, you'll notice we're just focusing on this, knowledge representation. And the context that I'm talking about is that artificial intelligence, machine learning that we mentioned when we talk about data science, right? During the prelim part, if I'm not mistaken. We mentioned this machine learning, that when we talk of data analysis or data science, we touch on this, machine learning and artificial intelligence, and these are like very important. So that's the context of this knowledge representation here now, because a human knowledge, and then we have like, it's different from machine knowledge, no? Okay, so something like that. Okay, this knowledge representation, we're talking of representation in, not in human, but in machine. Okay, and this is part of the artificial intelligence, the machine learning. Machine learning is like part of or a type of artificial intelligence, but still they have differences, these two. Despite that, it's a type of artificial intelligence, and that's what we want to discuss first, using a website, to differentiate the two before we go into the details of this knowledge representation, because this knowledge representation class is based also on how do I say it? It's like a research paper, no? The content of this is based on a research paper, so a viewpoint of the researchers, no? So possible from a different website, it may have another view that may be agreeing or in conflict, no? Something like that, no? Okay, but there's something that we can get also from this discussion, this lesson on knowledge representation, from the view of these researchers. Okay, but first, let's understand the context, because this one is used in AI, artificial intelligence, and to be more particular, machine learning. Okay, let me go to that website to differentiate the two. So I suppose you can see it now because I can see it on my screen. So let me just show you first the source, so that because we'll not discuss all of this, you can just refer to this later and read by yourself. Okay, this website, analytic insight .net. Okay, let me read some parts here, class. Now, what makes artificial intelligence so different from machine learning? Most common people tend to use the terms like artificial intelligence and machine learning as synonymous, and they do not know the difference. However, these two terms are actually two different concepts, even though machine learning is actually a part of artificial intelligence. As I mentioned, it's a type of artificial intelligence. It can be said that artificial intelligence is a vast area of topics. In fact, it's a technology, just like internet, no? Internet is a technology, nanotechnology is a technology, and this emerging technology now, the blockchain technology, which is the technology behind the digital currency, the cryptocurrency, the e-wallet, and so on and so forth, and others. It's a broad technology, it's emerging these days, the blockchain technology. Artificial intelligence technology is not new. It's not something new. In fact, I'll show you examples of where these are applied now, and probably you know already, right? Okay, where machine learning consists of a small part, so just small part. But even though it's a small part, machine learning can be like one course, for a term, or even artificial intelligence. But this one class will spend like one session or two sessions for this only, this discussion on, because we will just focus on knowledge representation, and we want to know where is knowledge representation in the context of artificial intelligence. Where is it? Okay, so that you'll appreciate the discussion later. It's not like too abstract and too technical, and you can see also the application, why it's important to discuss that knowledge representation. And later you'll find out it's like part of a cycle, that knowledge representation. And I'll show you that cycle later of an AI system. So here are the major differences between them, okay, before we talk of that cycle. Artificial intelligence is a field of computer science. So it's a field in computer science. So I suppose you will have a course in this, no? As I mentioned. Okay, that makes a computer system that can mimic human intelligence. Okay, that's the idea, right? Of artificial intelligence. That's why artificial, to mimic human intelligence. Okay, we want to come up with that. We call it agent, or machine, no? That makes a computer machine, a system, no, that can mimic human intelligence. And knowledge and representation is part of it. And how to mimic human intelligence, that this like one role of the knowledge representation that it will play. In fact, later on class in the module, that's what we will talk about now, the roles of knowledge representation in the AI system. Okay, and to understand that discussion better, let's know this two first, no, artificial intelligence and machine learning. So this obviously comprised of two words, no, artificial and intelligence, which means a human-made thinking power. So the artificial intelligence system does not require to be pre-programmed, no? Pre-programmed. Instead of that, they use such algorithms, which we discussed in the previous lesson already, right? Algorithm analysis, no? And so by this time, you know already, no? And besides, most of you, if not all of you, majors, computer science major, right? Which can work with their own intelligence. Okay, so that's the thing now. They use such algorithms which can work with their own intelligence. So we're talking of intelligence of a machine, no? Which is kind of rare, no? Because usually when you talk of intelligence of human, okay? But that's why it's called artificial intelligence. So it's possible to talk of intelligence of a machine because of this concept, this technology of artificial intelligence. It involves machine learning algorithms, so that makes it possible, na, that intelligence aspect, na, such as reinforcement learning algorithms, and also because of the algorithms that make it possible. And also this one, deep learning neural networks. But again, we cannot discuss this further. Okay, so on the other hand, machine learning. So what's the machine learning? On the other hand, machine learning enables computer system to make predictions or to take some decisions using historical data without being explicitly programmed. So this one based on historical data, na? But again, without being explicitly programmed. So these machines will just make prediction or make decisions based on historical data without being explicitly programmed. But how can this historical data be represented? That's where knowledge representation will take part. Okay, so regarding this historical data, this is like a form of knowledge also for the machine learning, a kind of knowledge, historical data. But how do you represent this? Okay, so machine learning uses a massive amount, no, of structured and semi-structured data, which we discussed in the previous lessons also, no, during the prelim part. Remember, we talked about data structures, structured, semi-structured data, so that a machine learning model can generate accurate results. And that's what we want, right? Accurate results or give predictions based on the data, that historical data. Okay. But later we'll have a discussion on this in the module regarding the accuracy of the result. No? That possible it's not that accurate also because of that role of knowledge representation that it plays, that we will discuss later. So machine learning works on an algorithm that learns on its own using historical data, the input, no? And the output is the accurate results. And the process there, the in between, is the algorithm, right? That makes it possible for the input to produce output, no? Through this algorithm. And this algorithm involves knowledge representation. Okay, so it works only for specific domains, such as if we're creating a machine learning model to detect pictures, for example, or of dogs. Okay, so this, like, for example, there's like an algorithm here to detect pictures of dogs. That machine, how can it detect pictures of dogs? Pictures of dogs can be knowledge, no? A type of knowledge or a form of knowledge. So how does knowledge representation help for this machine learning to detect these pictures of dogs? Okay, it will only give results for dog images, but if we provide new data like cat image, then it will become unresponsive, that machine or that AI agent, because it's not part of its historical data. okay, which is in the form of knowledge representation. Okay, so but if we provide, okay, machine learning is being used in various places. So these are like some applications, but later we have a website where we can see other applications no, of this AI, artificial intelligence or machine learning in particular. No, is being used in various places such as for online recommender systems, Google search algorithms. So this one you're aware of it because you use Google to search, right? And you might wonder how come these results are produced because of this machine learning that makes it possible. No? And that machine learning involves algorithm. Okay, email spam filter. How can filters email spam when you have this software? Because in that program, it utilizes machine learning or artificial intelligence, where it involves algorithms, and that algorithms, part of it is the knowledge representation. Okay, but again, where is that located? That knowledge representation. What part of the cycle? There's a cycle later that I will show you. Na? Okay, which is very important. Facebook auto friend tagging suggestions. No, probably you're aware of this if you have a Facebook. So how come um, uh, there is this thing no, that characteristic no, auto friend tagging suggestions, automatic, right? And that's possible because of the machine learning or the AI. Okay, so artificial intelligence is a poorly defined term which contributes to the confusion between it and machine learning. So I guess that's enough for the difference between the two. You can read the other part here. Okay, because it talks about deep learning also. It's another like topic, deep learning. Okay, and okay, so I leave the other part to you. So there's like Siri also mentioned here. The main applications of AI are the Siri, right? The Siri from the the Siri from the, for example, from the iPhone, right? How come it answers you? No, when you ask question, it answers you. No, and even with the voice. That's because of the application of AI. No, there's like a lot of algorithms there. Okay, and then it can answer you. No, okay, but of course, in that algorithm, if you talk in Tagalog, probably it will not understand because in the program, it only understands English. Okay, that's so language, we'll talk about that later. So it's part of the knowledge representation also because it's not represented the other languages. That is why this Siri cannot understand, no? Something like that. Okay, so that's the kind like the knowledge representation, no? Okay, the customer support using chatbots, no, expert systems, online game playing, and other examples mentioned in the class. Okay, let me show you that website. Where's that? The examples. And then it will talk more about also artificial intelligence this time, just artificial intelligence. So let me read it before I show you the examples. The term okay, let me show you first the website. So this is Java Point. Okay, you can refer to this. Probably if you want to explore this this website, there's more about talking about artificial intelligence, intelligent agent. Okay, we'll talk about this also. But it will just be mentioned as intelligent agent. But there are some details here. No, in that module, it's not discussed anymore. That's why if you want to know more about this, you can read this. No, okay. So knowledge represent. No, that what we'll talk about. This will be mentioned later. The inference, the logic, but very general. Even the first order logic. No, but here it's like a course. No, that you can. But in the module, it's just discussed. No, it's like mentioned only. That's why you need to class look at the context. No. Okay, so there's more about artificial intelligence. Okay, and this NLP. So anyway, just basic to understand the module. Okay, so the term artificial intelligence refers to the simulation, we know that already, of human intelligence processes by machines, especially computer systems, especially, yeah, this one. It also includes expert systems, voice recognition, machine vision, and natural language processing, the NLP. So AI programming focuses on three cognitive aspects, and we know that these cognitive aspects are present in human, and that's what we want to mimic, right, in our AI agent, as mentioned here, the agent, AI agent. We want to mimic these cognitive aspects of human, the learning, reasoning, and self-correction. So when you say learning process, this part of AI programming is concerned with gathering data and creating rules for transforming it into useful information. Okay, and as human, we do that, right? We can gather, we know how to gather, create rules for transforming it into useful information. The rules, which are also called algorithms. So For the AI class, that's become possible through algorithm. Offer computing devices with step-by-step instruction for accomplishing a particular job. So we're not just talking of one algorithm, can be a lot or more algorithms to be able to process this now, these learning processes in AI agent or in a machine or in a robot. Okay. And then we have reasoning processes. So again, we're talking of programming, no? But there's an algorithm involved again. So this part of AI programming is concerned with selecting the best algorithm to achieve the desired result. No? Okay, so that's a part of reasoning process. And the self-correction. Now, this part of AI programming aims to fine-tune algorithms regularly in order to ensure that they offer the most reliable results possible. Correcting that in the process now, self-correction. Okay, so artificial intelligence is an extensive field of computer science which focuses on developing intelligent machines. We don't want just machines, but we want our machines or robots to be intelligent. Okay, intelligent. And that will become possible through knowledge representation. Capable of doing activities that would normally require human intelligence, but because we're trying to mimic human, so through knowledge representation, may become possible now for intelligent machines, okay, to do activities normally human intelligence, where human intelligence is required. No? While AI is a multidisciplinary science with numerous methodologies, no, advances in deep learning. That's why if you're interested, you can just explore more on this. What is deep learning and machine learning? No, create a paradigm shift in almost every aspect of technology, such as this, the artificial intelligence. So these are like examples. Probably some of you have already experienced this, no, and the technology involved there is the artificial intelligence, no, the Google Maps, no. How come possible to give us direction through Google Maps, no? Because of the artificial intelligence. No? There are algorithms in that Google Map that becomes it possible. And that algorithm involves knowledge representation. And knowledge representation is part of a cycle, which I will show to you later. Okay, face detection and recognition. Okay, how come when we, for example, in the phone, we can without typing the password, no, if we just show our face, it will open, right? Or an app, it will be open if you just, because that's face detection, and that is possible through AI also. And again, there are algorithms involved, and then that algorithm involves knowledge representation, where knowledge representation is part of a cycle also. In other words, before that will happen, it should go through other components of that cycle first, no? Okay, so but that knowledge representation and reasoning, actually combined with reasoning, is the main components of this cycle, which I will show to you later. And it's very important because our focus for today's lesson is knowledge representation, not the other components of the cycle. No? And we'll just focus on this because these are like the main components in the AI system cycle that is at work in AI agent, in robot, or in a machine, no? Or in these applications. No? In these applications, the cycle is evident here, no? But of course, it's in the algorithm, no? It's under the chatbot. I suppose you know that, right? The chatbot, because there's like it will answer you. Now, if you ask a question and this chatbot recognizes some words there, then it can answer you, give you an answer, no? Okay. The Siri depends on how you pronounce the words, right? Because the Siri can answer a question if you say it verbally, no, not only typing it, no. But that one, it will depend on the word, on your pronunciation. That's why sometimes if you're wrong pronunciation, it will give you wrong answer, no. And that's part of the knowledge representation of that Siri. Because in the knowledge representation, his understanding is the English language, and based on that pronunciation also. So if you change the pronunciation, even though you're referring to that language, probably you will get a wrong output. Okay, unless you make a Siri wherein the context is pronunciation of the Filipinos, Filipinos talking English language. No, if you make it that context, yeah, possible, no. Okay, but still, we know that there are Filipinos who can pronounce words well. That's why it still can answer the question accurately, right? So, so that has to do with knowledge representation. The e-payments. How is this possible? Okay, and more. Okay, because of that cycle, where knowledge representation is part of it. So that's like the context, no? Okay, class. So I think I can go to that one. You can just, if you want the details of this, you can just go to this website. So let's maybe more specific now. So a while ago, we differentiate artificial intelligence with machine learning, and then we focus on artificial intelligence. This one, let's be more specific, and that has to do with our lesson today, which is knowledge representation. So here in this website talks now about knowledge representation, which is part of that context, no? Artificial intelligence, machine learning, which already differentiated a while ago. Okay, class, and we even talk more about it now in the other website, because we saw there other definition of artificial intelligence as well as the what is it, the processes, no? Should be present, the learning process, right, and other processes there, those cognitive aspects, no, that you want our machine to have, no, similar to the human, such as the learning processes and other processes mentioned in the other two. So this time, let's focus on this topic, which is the topic for today, the knowledge representation, and then we'll get another view of this in that lesson, okay, in that module that you have, no, for this course, no, and these are like enough context to understand it better, no. So here, class, what is knowledge representation according to this website? And this website is still Java, yeah, Java point, okay. So humans are best at understanding, reasoning, and interpreting knowledge. So here we're talking of how human represent knowledge, right? Human knows things, which is knowledge, and as per their knowledge, they perform various actions in the real world, right? Possible human have knowledge, but not necessarily intelligent, right? Okay. So here, class, we're doing the same thing now. We want our machine to have this knowledge. That's why we talk of knowledge representation. So how this knowledge represented in machine, no? And also be intelligent, no? Our machine, you want our machine to be intelligent, no? Because we want to mimic human behavior, right? We talk of human knowledge, we talk of intelligent humans. So in a way, we can also talk of here in this context of machine learning, no? Or artificial intelligence, no? But how machines do all these things come under knowledge presentation and reasoning? So how? Hence, we can describe knowledge representation as following: knowledge representation and reasoning. So you notice the reasoning is now connected to it now, because this one is like part of a cycle, no? Not just knowledge, but reasoning. When you talk of reasoning, somehow, it's like part of the intelligent behavior, right? The reasoning part, okay? So this KR or KRR, we also call it like that, is part of artificial intelligence, which is concerned with AI agents thinking. The AI agents here, class, we're referring to to those examples, no, to those machines, no, or to those examples, the chatbots and so on and so forth, no, the Google Maps, okay, and how thinking contributes to intelligent behavior of agents. Again, the agents refer to those, no, those examples, okay. It can be also robot, as in robot, okay, okay, class. So, and we can also talk of in the trading, no, trading class, no. Sometimes we can talk of robot there also, no, doing the trading, no. Okay, so that involves that's artificial intelligence also, no. When I say trading the stocks, even that, or the cryptocurrencies and so on, we also have that kind of technology, no. Okay, because that one, the only buy and sells, no. Because in trading class, that's what you do, right? Buy and sell. And then we make that robot to be like buy or sell only. The goal is not to lose money, no? Only buy but not losing money, or sell but not losing money. So that's the part of the algorithm of that robot, no? Or that knowledge presentation of that robot, because the goal for trading is not to lose money, no? But if the human will be the one, it's very prone to losing money, no? Because of this judgment, emotion. Whereas in a robot, which is part of artificial intelligence, we remove that part of the human. So in a way, we will talk about that later, no? Mimicking human behavior, but not exactly, no? It's like a substitute, surrogate. We'll talk about that later, the surrogate or the substitute, but not really copying exactly. Okay, so it's responsible for representing information about the real world. So representing information, so knowledge representation about the real world. Okay, so that a computer can understand. Okay, so that's the idea there, not machine understanding the real world, human understanding the real world, no? Okay, those two um, are different. However, the machine we're trying to mimic how human understands the real world, right? And can utilize this knowledge to solve complex real world problems. So that's ideas such as diagnosis and a medical condition or communicating with humans in natural language. So diagnosis is more like automatic, no? Diagnosis of a medical condition, right? Instead of human doing it, it's a machine already doing the diagnosis. And how is that possible? Through AI, the algorithms, no? Okay, that's why there is this an article or news spreading that in the future, probably the doctor will be replaced by AI, right? The human doctor, something like that. Okay, doing the operation. Instead of human doctor, it can be the robot already doing the operation. And there are like some studies on that. And that's part of AI class. Okay, a part of AI. So it's also a way which describes how we can represent knowledge in artificial intelligence. Knowledge representation is not just storing data into some database. No, it's not like that. So there's a analysis of that data that involves reasoning, no? But it also enables an intelligent machine to learn from that knowledge. So the learning process, remember we talked about that cognitive aspect of a machine, no? Similar to human, like learning, no? Process to learn from that knowledge and experiences so that it can behave intelligently like a human. That's why important the knowledge representation, because human or the machine learn from the knowledge, right? So how do you represent that knowledge in machine? And the machine will learn from it, no? Or analyze that knowledge, no? And come up with an output based on that knowledge, something like that. You understand this better in a cycle. So what to represent in the knowledge representation? Following are the kind of knowledge which needs to be represented in AI object, in AI machines. Now we'll talk about object also in the class, no? In the module. But important that you know that this is the context, no? Because other than object, we can have also events, performance, meta knowledge to represent by the AI, no? In the knowledge representation, facts, knowledge base, object, all the facts about objects in our world domain. Okay, again, we'll talk about this later in the module. We'll talk about formal objects, no? Natural objects later, no? Events are the actions which occur in our world. So how does machine represent this, no? A human, we experience events. That's how we represent, no? Our knowledge on events, no? But how about machines? Machines do not have emotions. So how do you represent this in a machine? Something like that. Through knowledge representation. Performance, it describes behavior which involves knowledge about how to do things, like procedural. Meta-knowledge, it's knowledge about what we know. Okay, facts are the truths about the real world and what we represent. Knowledge base, the central component of the knowledge base agent is a knowledge base. No? It's represented as KB. So these are like what to represent, no, in knowledge representation. And I think, yeah, later we'll talk more about this, but the other here will not be mentioned there in the module. But if you're interested, you can explore more on this, you know, how to represent this in AI. Okay, knowledge is awareness of familiarity gained by experiences of facts. So by experiences, human have this experiences, but how about machine? Okay, that's why we talk of knowledge representation for machines. No? Following are the types of knowledge in artificial intelligence. No? The types of knowledge like this one, declarative knowledge, procedural knowledge. Now, declarative knowledge like the facts. No? Procedural has to do with procedure. Meta knowledge, okay, other knowledge, other types of knowledge is called meta knowledge. Heuristic knowledge, no? Okay, structural knowledge. So this one has to do with problem solving. Now, heuristic knowledge has to do with knowledge of some experts, no? So how do you represent that in an AI agent or in a machine, no? Okay, so I can go to so much details on this. If you're interested, you can go to that. Now, what's the difference between knowledge and intelligence? Because we mentioned already about intelligence, right? So knowledge of real words plays a vital role in intelligence, right? Because that's, I don't know, like a prerequisite, no? For a human or to be intelligent, you should know knowledge, no? Whatever that knowledge is, no? Similarly for machine, no? That's why important for the machine to how to represent this knowledge, no? This knowledge, these types of knowledge, so that it will become an intelligent AI agent or exhibit an intelligent behavior. That's what we want for our AI, no? Agent, no? And same for creating an artificial intelligence. Okay, class? Knowledge plays an important role in demonstrating intelligent behavior, as I mentioned in AI agents. An agent is only able to accurately act on some input. The input is that one, based on this knowledge, when he has some knowledge or experience about that input. Okay, the AI agent. Remember we talked about that image of the dog and the cat, because he has the historical data involves the image of the dog. So if you present an image which is not part of the historical data, that AI agent will not respond. Okay, so that's why important that knowledge representation. Let's suppose if you met some person who's speaking in a language which you don't know, and then how you will be able to act on that? Like the Siri, right? This one person. How about for the Siri? The Siri is a machine, right? Or like an algorithm. It doesn't recognize Filipino words, no. So it will act, but it can be wrong. Wrong result, no. Sometimes it will not respond. That's the one represented in the algorithm, the knowledge representation. In the algorithm, if you cannot recognize it, just don't do anything. But we know that in Siri, even if we talk in Tagalog, sometimes it can give some results, no, and wrong results, no? Okay, because the wrong input. Okay, the same thing applies to the intelligent behavior of the agents. Okay, so it can produce wrong input, a wrong output. As we can see in below diagram, now I can talk of not yet, but we're close to that cycle. Okay, as we can see in below diagram, there's one decision maker, no, here, which act by sensing the environment and using knowledge. But if the knowledge part will not represent present, then it cannot display the intelligent behavior. And we can see it in the action, right? So you have an AI machine. There is like a sensing there. So this is like the AI machine or AI agent, sensing and knowledge representation, and then action. Okay, so okay, class. So this is the knowledge cycle that I'm talking. This one is related to the knowledge cycle. So this is the cycle that I'm talking about. You notice the knowledge representation mentioned here. So that's our lesson for today. So it's part of this cycle, no? And it's connected to reasoning. No? Okay, so perception, learning, then knowledge representation. How to represent this learning, no? This knowledge based on this learning, no? Or perception. Okay, and how do you connect reasoning here to come up with planning? And actually, this one is execution. No? In a way, the output of that, the example that we had a while ago, no, the output. For example, the chatbot, no, the input is you type something, right? You type there, you ask question, and then if that chatbot, has algorithm inside, recognizes the words or the questions, and then it will give you output. Okay, based on the knowledge representation in the algorithm, it will be based on that, no, and it will give you the execution is the output. Okay, the above diagram is showing how an AI system can interact with the real world. The AI system can interact with the real world. Okay, and what components help it to show intelligence? Okay, AI system has perception component by which it retrieves information from its environment. It can be visual, audio, or another form of sensory input. Okay, for the chatbot, the input there is the typing, the information that you type there. No, the learning component is responsible for learning from the data captured by perception component. So that's the learning, the understanding of that chatbot. No, in the complete cycle, as I mentioned, the main components are knowledge representation and reasoning. These two components are involved in showing the intelligence in machine-like humans. These two components are independent with each other, but also coupled together. No? Independent but coupled together to come up with the planning and execution. The planning and execution depend on analysis of knowledge representation. It depends on the, remember, this one, the knowledge representation will depend on the learning, right, and reasoning. But the execution and the planning will depend on this two also. So it's like this one is in the middle, no, in the cycle. That's why the main components the main components. But this one will not be executed. I mean, this knowledge presentation will not be implemented if there's no perception and learning. So that's why it's a cycle. And without this knowledge presentation, there will be no output. No, there's no execution. We cannot feel the benefit of that that example. So those examples that I mentioned a while ago, no? If there's no execution and planning based on the knowledge representation reasonings. And this is our focus of the lesson today, class. No? This one. Okay, so the other I cannot read anymore. Approaches to knowledge representation. If you're interested, you can read this more. I'm not so sure if we have like a dashboard also. There's none. This unlike the other website. So there's another one class. It's still also focusing on knowledge representation, but I think it's like a repetition of what I showed to you a while ago. It's just that this one, for the cycle, there's like a detailed discussion on the perception, no? Okay, this one. But I think already repeated, no? We mentioned this already there in that website, and also this, right? We also mentioned this already. So this one like detailed only for the components, no? Okay, just very fast. So the perception component retrieves data or information from the environment. With the help of this component, you can retrieve data from the environment, find out the source of noises, and check if the AI was damaged by anything. Also, it defines how to respond when any sense has been detected. Then the learning component, that learns from the captured data by the perception component. The goal is to build computers that can be taught instead of programming them. That's why we mentioned, right, in the difference of AI, there's no need for self-programming or explicitly programming it, right? Though there's an algorithm, but because of this cycle, it's possible, no? The goal is to build computers that can be taught instead of programming them, no? So teaching a machine, no? Learning focuses on the process of self-improvement. In order to learn new things, the system requires knowledge acquisition. So knowledge acquisition, so that it will be represented here later, no? Inference, acquisition of heuristics, faster searches, etc. So the main component of the cycle is the knowledge representation and reasoning, which shows the human-like intelligence in the machines. Okay, so that's why important. Knowledge representation is all about understanding intelligence. Instead of trying to understand or build brains from the bottom up, which is impossible, its goal is to understand and build intelligent behavior from the top bottom. Okay, top bottom. And focus on what an agent needs to know in order to behave intelligently. Okay, so it depends on the program plus, no, what it wants to achieve, no? This one, to know in order to behave intelligently. Also, it defines how automated reasoning procedures can make this knowledge available as needed. So the planning and execution, as I mentioned, execution, no, not education. The planning and execution components depend on the analysis of knowledge representation, the analysis of this and reasoning. So that's why what to analyze if we don't have knowledge representation, right? So that's why important the knowledge representation. Here, planning includes giving an initial state, finding their preconditions and effects, and a sequence of actions to achieve a state in which a particular goal holds. Now, once the planning is completed, the final state, the execution of the entire process. And that's where we get the benefit, right, of the software or the machine. Okay, that's why we create a program or a machine because of this final stage, no, the execution. Okay, we want we know the thing in end, no, before we develop an AI agent or a machine or a robot, no, before we develop that, we have something, a goal in mind, and that's part of the execution, the final stage. So these are the different components of the cycle. Knowledge representation in AI. Now, okay, so I guess this one talks about the relationship between knowledge and intelligence, which I guess we talked about a while ago already. Yeah, I think we did because we talked about this, right? So in the real world, knowledge plays a vital role in intelligence as well as creating artificial intelligence. Demonstrates the intelligent behavior in AI agents or systems. Okay, it's possible for an agent or system to act accurately on some input only, but can be inaccurate on some input because it will act accurately on some input only when it has knowledge or experience about the input. So this knowledge or experience has to do with knowledge representation. And that's what we will focus on today's lesson. What are these roles? No? Okay, let's go to that one now. I think that's enough for the context to appreciate the lesson for today, which is full of concepts and technical terms. No? So let's proceed to that one. That's enough with the context. Let's go to this one class. No? Knowledge representation and knowledge That's knowledge theory. But again, as I mentioned, the focus is knowledge representation. This one is involved only because of the origin of knowledge, no? But it's more philosophical. So in other words, we're talking of like the origin of knowledge for a machine. Because this one philosophical, more of human, talking of the origin of knowledge in human, the existence of knowledge in human. But here, class, we were kind of talking of origin of knowledge in machine. Okay, but the focus is knowledge representation. That's why this knowledge theory is just mentioned in the title, not anymore inside. Okay, class. So let's dive in. So these are like the okay, we define knowledge representation. So somehow we already achieved this, but what does the author have to say about this? No, the researchers have to say about this. No, the researchers of this module. Okay, determine the roles. So that's the thing that we will talk about. The roles played by the knowledge representation, not discussed in other references, no, but discussed here in this paper. Okay, distinguish a KR from data structure, which we talked about before already, no, the data structure. So what's the difference between the two? So let's dive in. So knowledge representation. What is a knowledge representation? We argue, so these are the researchers, that the notion can best be understood in terms of 5 distinct roles it plays. So that's the way this module or these researchers look at knowledge representation. Though a while ago, we saw the understanding of this, right, in another like view, in a way related also to this, no? Okay, it's crucial to the task at hand. So here, class, we have 5, but we'll focus more on the 3, especially if we don't have time. No, in fact, there's like a part 2 of this. So if you have time in the part 2, probably we'll talk about the other 2 roles. No, but for this module, it only talks about the 3 roles. Now focuses on the 3 roles. So what are these 5, or what are these 3? So the first one is this one. A knowledge representation is most fundamentally a surrogate, a substitute for the thing itself, used to enable an entity to determine consequences by thinking rather than acting. That is, by reasoning about the world rather than taking action in it. So here, class, we're talking of the AI agent, no? Or the machine, or the robot, or the chatbot, no? Or other examples that we mentioned a while ago, that we want our AI agent to be, it's a surrogate substitute for the thing itself, but we want it to be thinking, not just acting, no? Reasoning about the world rather than just acting on it, no? Meaning, it's not that we don't want action. In fact, there's execution, right, in the cycle and planning, but we want it to be not impulsive like human. Human, we know, that's impulsive decision, right? Impulsive action. So we want something like, if you're gonna act, if you want our intelligent, that's a way for it to become intelligent AI agent, no? It doesn't act impulsively like human. It has to be based on thinking and reasoning before action. So that's the one we want in our AI. Though we're trying to mimic human behavior, but we'll find out later that the surrogate here, substitute, meaning there's the implication of not really the exact copy, because we know that there are things in human not also good, like that one, impulsive, no? We don't want our machine or our robot to act impulsively, no? We want our robot, or we want our AI agent, or whatever that artificial intelligence application is, to be to base the output on thinking, on reasoning, right? Instead of just giving action result without thinking or reasoning. Okay, I suppose we'll discuss this in detail later. Because as I mentioned, we'll discuss in detail the 3, and this is part 1 of the 3. The second one is this one. It's a set of ontological commitments, an answer to the question, in what terms should I think about the world? So it's like kind of philosophical, because when you talk of ontological, it's philosophical also. So in a way, it's for human question, but we want our machine to be thinking this way also. In what terms should this machine think about the world, this AI agent, no? Okay, we'll talk about the details of this later, no? Or in part 2, if you don't have time. It's a fragmentary theory of intelligent reasoning. So again, That's what we want, right? Not just reasoning, but intelligent reasoning, expressed in terms of three components. The representation's fundamental conception of intelligent reasoning. Okay, how does knowledge representation conceive this idea of intelligent reasoning? Because for human, we have that, right? When we say intelligent reasoning, right? For human, but how about for a machine? Okay, or for the AI agent, no? What will be the knowledge representation for that? The set of inferences, the representation sanctions. No, again, this is another concern. No? The inferences. A human do this, right? The inferences. Excuse me. So how do we represent that in the knowledge? No? These inferences, and then the set of inferences if recommends. So what inferences should be recommended to be part of that algorithm of the AI agent or the machine or the software or the program. No? Okay, and these are the three that we will focus on. But if we have time in part 2, probably we'll talk more about this also. But if you will notice in your module, the focus is only on the 3. But if you're interested, you can explore more on this. Okay, let me just read it. It's a medium for pragmatically efficient computation. That is the computational environment in which thinking is accomplished. Okay, that one. One contribution to this pragmatic efficiency is supplied by the guidance a representation provides. So again, knowledge representation for organizing information so as to facilitate making in the recommended inferences. Okay, but the focus here is more on the computational part, accurate computation. Okay, it's a medium of human expression. The AI is a medium of human expression, though it's not human, but we're trying. It's artificial intelligence trying to mimic human behavior, right? Somehow the role it plays is it's a medium of human expression. That is a language in which we say things about the world. Okay, like the one I mentioned, the Siri, the language there is the human expression is there. The medium there is English language. So that's part of the knowledge representation in Siri. So if you use other languages, not possible, but definitely, it may ask you to repeat that because probably it can't understand, or it's also try to understand it based on the knowledge representation that is part of the algorithm, and then answer you, but the answer is wrong. Okay, that's why this one is also important. No? A language in which we say things about the world. Okay, or it can be other language, not only the speaking language that we're talking about. Okay, it can be another meaning of language. Okay, class. So again, we will not focus on this 2, but only the 3. Okay, class. But again, if we have time, we will try to discuss some details about this. Okay, so let's dive into the. But before that, what's the importance of these roles? Now, before we go to the first role, understanding the roles and acknowledging their diversity has several useful consequences. These 5 roles, from the viewpoints of these researchers, first, each role requires something slightly different from a representation. Okay, mentioned in other websites. Okay, each accordingly leads to an interesting and different set of properties you want a representation to have. Okay, so it may lead to that, discussion. In fact, later we'll talk about that. Second, we believe the rules provide a framework useful for characterizing a wide variety of representations mentioned in different websites. So this will provide a framework. These people who talk about knowledge representation probably agreeing each other or in conflict to each other. May talk of a framework which will lead them to an agreement, something like that. Okay, so we suggest that the fundamental mindset of our representative can be captured by understanding how it views each of the roles, and that doing so reveals essential similarities and differences. Okay, regarding those representations mentioned in different websites. Okay, and probably come up with agreement. That's why it's mentioned in the third. Third, we believe that some previous disagreements about representation are usually disentangled, meaning can be resolved when all 5 roles are given appropriate consideration by these people who've given their views about knowledge representation. So if you will look at these 5 roles, probably you may reach an agreement regarding understanding this knowledge representation. We demonstrate this by revisiting and dissecting the early arguments concerning frames and logic. Frames logic, part of that, but we will not talk about it. I think I mentioned this to you a while ago in that website, in another website, wherein we'll not talk about this, but it's like part of the knowledge representation also. These frames and logic. Okay, and part of the algorithm, which we will kind of mention also slightly or in passing later, no? And other tools, no? Because it's like part of the what you call KP technologies, no? Which we will discuss later, no? But not in detail, but again in some details. Okay, so finally we believe that viewing representations in this way, meaning the 5 roles, has consequences for both research and practice, like an application. No, it's like important if you make research about AI, artificial intelligence. This is like a good may lead to good results, no, for both research. Okay, if you view representations in these 5 roles, no, for research, this view provides one direct answer to a question of fundamental significance in the field. So that may be the consequence for research, no. What is the significance of this knowledge representation in AI, in artificial intelligence or machine learning? No? When you look at these 5 roles, no? When you do the research, it also suggests adopting a broad perspective on what's important about a representation. Okay, so broad perspective, not like narrow perspective. Okay, because other views on broad knowledge can be narrow, not broad. So if these people will consider these 5 roles, probably their narrow perspective will become broad perspective about, there's like aha moment, no? Like, oh, I understand, something like that, no? When they look at these 5 roles. So that's the idea here, no? And it makes the case that one significant part of the representation endeavor is capturing and representing the richness of the natural world. No? That's the idea there. The significant part of knowledge representation, capturing and representing the richness of the natural world. And this richness of the natural world, we can talk of those objects. I mean those types of knowledge we talk about that can be in the form of object, event. Remember those things. Okay, and later we'll talk about objects, no? Okay, because this one receives insufficient attention. Okay, that's the narrow perspective, no? If you don't consider this a significant part, no? Significant part. But if this is viewed in terms of the 5 roles, and that will lead to a broad perspective, okay, and in a way, it will receive sufficient attention. So we believe this view can also improve practice, no? By reminding practitioners about the inspirations that are the important sources of power for a variety of representations. So when you say practitioners class, those are like developers or of those AI agents, no? Like for example, the chatbot. No? So that's focused on the application of the technology, because as I mentioned, AI is a technology. No? If you focus most on the research, you're a researcher, no? Meaning the science of that, the science, the knowledge behind it, no? That's part of the science in a way, not science work, no? But if you focus on the application of that science, which is the artificial intelligence, then we talk of technology, and usually those are the practitioners focusing on the application. Those examples we talk about, those are like applications. So those who develop them are practitioners. Of course, they are researchers also, but they focus more on the practical aspect of this technology. The research focus more on the science aspect or the knowledge part of the research part of this technology. Okay, class. So that's the difference between the two. So here, class, the consequence for the practitioner is that it improved the practice, no, by this practitioner about the inspirations, meaning it gives them inspirations, no, when they focus on these 5 rules of knowledge representations, they give them some inspirations regarding what are the important sources of power for a variety of representations or knowledge representations when they consider these 5 rules. Okay, this is like the importance of this research paper, no? On the knowledge representation, on the knowledge representation in terms of the 5 rules, that we mentioned a while ago, but we will discuss only the three. And I think we can discuss now the first one. Again, but before that, there's more about it. The terminology and perspective. No? This one is very important. I mentioned about this a while ago. Knowledge representation technologies. No? So 2 points of terminology will assist in our presentation of these 5 roles. No? First, we use the term inference in a generic sense, not in a logical inference that we used to. Okay, what do we mean by this? To mean any way to get new expressions from old. So that's in a generic sense of when we talk of inference, inferring. Human do this, right? So we want our AI agent or our machine to do inference as well, but in a generic sense, not like the logical inference, because human usually does the logical inference, no? Type of inference, no? The sound logical. So we are only really talking about sound logical inference, and when doing so, refer to that explicitly, no? So this is what we mean, the generic sense. Any way to get new expressions from old. That's the inference that we're talking about here. Second, to give them a single collective name. We refer to the familiar set of basic representation tools. Remember, we mentioned about logic and frames and other representation tools. When we do knowledge representation in an algorithm, right, in the form of algorithm, and usually we use this in algorithm, right? Logic, rules, frames, semantic net, etc. And here, class, we just put a single name to this one. We just call it knowledge representation technologies. But actually, we're referring to this, no? Which we cannot discuss in detail anymore, no? So just think of it like part of that algorithm, okay? In making this knowledge representation, okay? Not just algorithm, but sets of algorithms, no? When we're talking about that, no? Okay. It will also prove useful to take explicit note of the common practice of building knowledge representation in multiple levels of languages. Remember, we talked about the language in Siri, right? Typically, with one of the knowledge representation technologies at the bottom level. But as I mentioned, we're not just talking of speaking language. No? It can be like this language. No? Hayes' ontology of liquids, for example, is at one level a representation composed of concepts like pieces of space that have portals, spaces, sites, etc. So the language at the next more primitive, as it turns out, bottom level is first order logic. Remember, this is mentioned in the website, the first order logic, where, for example, this one, in S1, S2. For example, in algorithm, this can be understood as a relation expressing that space S1 is contained in S2. So that's like a language, no? Multiple levels of language in knowledge representation. This one is building knowledge representations, okay? So now this view is useful in part because it allows our analysis and discussion to concentrate largely on the KR technologies now that we mentioned a while ago, these KR technologies, remember? These logic, rules, frames, semantic nets, like part of the algorithm, okay, which is part of the AI agent, right? Or the those machines, no? So this view is useful in part because it allows our analysis and discussion to concentrate largely on the KR technologies. At the primitive representational level, at the foundation of KR languages, they encounter all of the issues central to knowledge representation of any variety. So they are also useful exemplars because they are widely familiar to the field and there is substantial body of experience with them to draw on. Okay, class? So now, what is knowledge representation? Perhaps the most fundamental question, this has been the question a while ago, no? So we're going back to this question because to remind us that, again, we believe that the answer is best understood in terms of the 5 fundamental roles that it plays. As we already mentioned at the beginning, right? We're just reiterating it because this one, the we here is the other researchers class now, because we will discuss now the first one, okay? And the first one is KR is a surrogate. Okay, so as we mentioned, surrogate meaning substitute, no? Any intelligent entity, so meaning the AI, agent, or the machine that wishes to reason about its world encounters an important and escapable fact. And what is that? Reasoning is a process that goes on internally, while most things it wishes to reason about exist only externally. Okay, so how do we make it internal reasoning? No? A program or person engaged in planning the assembly of a bicycle, for instance, may have to reason about entities like wheels, chains, sprockets, handlebars, etc. Yet such things exist only in the external world. So how do you make it internal in an intelligent entity or in an AI agent? No? Okay, so that like part of the knowledge representation. No? So this unavoidable dichotomy is a fundamental rational enroll for a representation. Okay, the surrogate role for a representation. It functions as a surrogate inside the reasoner. Okay, internal reasoning. I stand in for the things that exist in the world. So that's the knowledge representation. That's how you make it internal reasoning instead of external reasoning, because we view knowledge representation as a surrogate, and knowledge representation in the form of algorithm. No? So in that way, we can do internal reasoning in that way, no? Based on the algorithm. So it functions as a surrogate inside the reasoner, a stand-in for the things that exist in the world. Operations on and with representation substitute for operations on the real thing. So substitute. No, that is substitute for direct interaction with the world. Direct interaction, substitute for the direct interaction with the world. No? That's why surrogate. No? So direct interaction with the world. So human do this, right? But how can machine do that? Direct interaction with the world in the form of knowledge representation, which is in the algorithm. So in this view, reasoning itself is in part a surrogate for action in the world. No? The reasoning, okay, itself is in part of a surrogate for action in the world. That's why, as mentioned earlier, a knowledge representation and reasoning are independent. However, they are also coupled together. No? So reasoning is part of the knowledge representation, coupled together, but also independent. Okay, so when we cannot or do not yet want to take that action. Okay, so that's the thing here about reasoning. All right, class, now, viewing representations as surrogates leads naturally to two important questions. So what are these two important questions? The first question is about any surrogate is its intended identity. What is it a surrogate for? Okay, this substitute, no? There must be some form of correspondence specified between the surrogate and its intended inherent a referent in the world. Okay, this surrogate class has to do with knowledge representation. No? It's like a surrogate, no? A substitute for the intended referent in the world. But there must be a correspondence, no? And that is possible through semantics. No? The correspondence is the semantics for the representation. And what is the semantics? It's part of the, remember knowledge, KRT, knowledge representation technologies, as mentioned here, no? The semantic, no? And it's part of the algorithm. Okay, class, that's how you do the surrogate, no? How do you make the surrogate and its intended referent in the world to be in correspondence using the semantics in the algorithm, no? Okay, so that intended referent in the world should be part of the algorithm, and that's possible through semantics for the knowledge representation. Okay, so those are like connected to the substitute. Okay, associated to the substitute. Okay, what is the second question? Aside from identity, that's the first question. So it's like a question of a human, my identity, the human identity, no? So we're trying to copy what the human question. What am I for? Something like that. Now this one, what is it a surrogate for? So how about the fidelity? That's another question. How close is the surrogate to the real thing? Okay, like, so it's not like loyalty, no, the fidelity. It's more of like copying the exact thing, no, this fidelity, no. How exactly surrogate copying the real thing, no? Or okay, so this has to do with another class, no? Copying the real thing. What attributes of the original does it capture and make explicit? Okay, in the knowledge representation, no? Remember, we're trying to represent knowledge, and knowledge can be different types. It can be object, event. So how can you copy the real thing, no? How can the surrogate or this AI agent, no, copy the real thing, no? The original. Okay, and which does it omit, no? Perfect fidelity is in general impossible. So that's impossible, no? Both in practice and principle. So it's impossible to achieve this, no, this exact copy in a surrogate, no, whether we put it in algorithm, no, it's impossible in principle because anything other than the thing itself is necessarily different from the thing itself. So original is original, copied is copied, no, something like that. in location, if nothing else. Put the other way around, the only completely accurate representation of an object is the object itself, right? The real thing. Okay, all other representations are inaccurate. Okay, they inevitably contain simplifying assumptions and possibly artifacts. And this is this important class in algorithm, no? So in a way, kind of disadvantage or advantage, no, of making an algorithm, because in algorithm we simplify assumptions and possibly artifacts. That's why we cannot get the complete copy of the exact one. So it's not an accurate, it doesn't make an accurate representation of an object. Okay? And because of that class, there are two minor elaborations that there are two important questions and there are two minor elaborations. Extend this view of representation as surrogates. First, it appears to serve now we're talking of objects here, no? First, it appears to serve equally well for intangible objects as it does for tangible objects. So we're talking here of objects that can be touched and objects that can be touched. Okay, remember this is like a type of knowledge also. The tangible object like gear wheels, no? Representations function as surrogates for abstract notions. No, this is like intangible, no? Like actions, processes, beliefs, causality, categories, etc., allowing them to be described inside an entity so it can reason about them. Now, second, the formal objects. No, other than the tangible, intangible, abstract, we can also talk of formal objects, no, as a knowledge, as a type of knowledge. Okay, formal objects can of course exist inside the machine with perfect fidelity. This one we can copy exactly because we're talking here of like mathematical entities, for example, can be captured exactly, precisely because they are formal objects. If they are formal object type, it's like mathematics, right? It has a system. It's organized well. Okay, so that's why we can have perfect fidelity or we can copy this formal object. However, for the tangible, intangible, we cannot copy exactly, no, accurately. Okay, so how will it affect the output of the AI if that's the part of the knowledge representation? Okay, we'll find out later. Since almost any reasoning task will encounter the need to deal with natural objects, again, natural objects, these are the objects in the real world. So this can be the can be living things or non-living things, no? Can be the plants, the animals, or even the non-living things, no? As well as the formal objects. Imperfect surrogates are pragmatically inevitable. Okay, so meaning unavoidable to have imperfect surrogates because they cannot really copy these objects accurately. That's what makes surrogates imperfect. Okay, so those are the two minor elaborations. However, it still talk about the two important consequences of this. The imperfect surrogates mean incorrect inferences are unavoidable also. Because the surrogates are imperfect, so the inferences can be incorrect. So what are the consequences of these two from the imperfect surrogates, which is cannot be avoided? One consequence is that in describing the natural world, we must inevitably lie. So error, no? Remember natural world, we talk of natural objects, no? At a minimum, we must omit some of the effectively limitless complexity of the natural world. That's why we simplify as mentioned here, kind of simplifying the assumptions, no? Simplifying assumptions, no? When we talk of the natural world, no? Okay, so there is a need for that, and the consequence will be an error. There can be like you have to omit, no? So our descriptions may, in addition, introduce artifact not present in the world, or addition not present in the world. Not only error, but also addition not present in the world. Okay, class. And then the second and more important consequence is that all sufficiently broad-based reasoning about the natural world must eventually reach conclusions that are incorrect. That's another consequence, no? Incorrect conclusion. Independent of the reasoning process used and independent of the representation employed. So sound reasoning cannot save us, no? Even though there are coupled together knowledge, representation, and reasoning, but sound reasoning cannot save us. So if the word model is somehow wrong, some conclusions will be incorrect. Okay, because not accurate, no? Because the surrogate is inaccurate or imperfect, so there's a possibility of incorrect conclusion. Okay, because the algorithm that's modeled is somehow wrong when it comes to knowledge representation. So the output, remember in the cycle, we have the planning and execution. So the result in the analysis will eventually be incorrect conclusion. So no matter how carefully drawn, a better representation cannot save us. All representations are imperfect, and any imperfection can be a source of error. Okay, so that's like one disadvantage of imperfect surrogate. Impossible to have because it's impossible to have perfect surrogate also. So because of that, it can be a source of error. So how to minimize this? Okay, the significance of the error may of course vary. Indeed, much of the art of selecting a good representation is in finding one that minimizes. So that's the thing. Okay, the knowledge representation is as a surrogate is prone to error. So how to minimize that? Minimize or perhaps even eliminates error for the specific task at hand. But the unavoidable imperfection of surrogates means we can apply at least one guarantee for any entity reasoning in any fashion about the natural world. If it reasons long enough and broadly enough, it's guaranteed to make error or to err, to make error. So meaning the reasoning is broad, If the reasoning is broad, that's in the algorithm, it's prone to error. So why don't you make it like the reasoning in the algorithm can be like specific and short. Probably we can minimize the error in that way. So drawing only sound inferences, that does not free reasoning from error. Does not free reasoning from error. This sound and inferences. You can only ensure that inferences is not the source of that error. Okay. Because this one can be because of imperfect surrogate. Given that broad-based reasoning will inevitably be wrong. So the step from the sound inference to other models of inference is thus not a move from the total accuracy to error, but instead a question of balancing off the possibility of one more source of error against the gains it may offer. Like for example, remember we talked about efficiency of algorithm before, right? So that can be a gain. But of course, there also a source of there may be a source of error for that algorithm. So to minimize it, balance the two. The gain and the loss in a way, because it's unavoidable, the errors. So but just balance that too, make your algorithm efficient, so probably it can minimize the error. Okay, that this AI agent or this machine may produce, so it's prone to error, even if it's a machine, a robot, it's still prone to error. There's no such thing as, because of that, this role of knowledge representation, which is a surrogate but imperfect surrogate. Okay, class. So we do not suggest that unsound reasoning ought to be embraced casually, but do claim that given the inevitability, so we cannot avoid the error even with sound reasoning, it makes sense to evaluate pragmatically the relative cost. So we talk about cost and benefit now, because remember, this involves cost and benefit. If you want to produce chatbot, or if you want to make these applications of artificial intelligence, that involves money, right? So because of this error and balance off with efficient algorithm, somehow there's a need to cost and benefit analysis, the advantages of producing that artificial intelligence agent. Is it worth it? So you have to make this cost and benefit analysis because of that error, which can be minimized by making your algorithm involved in the knowledge representation efficient. And then after that, do the cost benefit analysis. If it was worth it to continue that that AI agent, or to develop that AI agent or machine. Okay, class. So now for the next lesson, we'll talk about this one, the other role. Okay, for the next lesson. So I'll end here, class, and we'll have part 2 of this lesson. So that ends the session for today, but not the lesson. Okay, class. So thank you very much for attending.